Welcome to the presentation of fire safety training. I am your host, Paul. It's good to meet you. And let's activate. Introduction. This training combines the information on both the fire prevention training and fire extinguisher training. This training is not intended to make its users into professional firefighters, obviously, but to make them, being you, knowledgeable of some fire dangers, some preventative actions, and the different types and purposes of the fire extinguishers. Can you hear me okay? All right. Question. If you see, are you going to be like this all day? Yes, you are. Right? Not intended to make you a firefighter. If you see a fire, what do you do? Anybody? Run for cover? Duck and cover? That's something completely different. Stop, drop, and roll. I am so not happy with the way this program's going. We had the same problem over at with our last presentation, didn't we? Yeah. Race. That's what you do. The first R in race is actually rescue, but we are in a unique situation where every one of us carry radios. And so for our particular purposes, what we want to do is very first, as soon as we see a fire, is radio the FPO. That way we can get all hands on deck. That we can do while we're looking around to see about rescue. But for the race, which used to be RCAF, do you remember RCAF? It's like, how can you remember RCAF? You know, unless you're someone who works on a farm, you're not going to remember RCAF. But race is a little easier to remember. Race. Rescue, alert, contain, confine, extinguish. So the first step is to rescue. Now, again, we add to that radio FPO because it's so easy to do while you're looking to rescue somebody. You rescue any victims and remove them from the area, unless doing so would trap or endanger you. So the first thing you do is check for victims. You radio the FPO and let them know where the fire is, how large the fire is, and what type of fire it is if possible, and if there's anyone needing rescue. When you're rescuing somebody, you always ensure that you have free egress and are able to pull someone out, that they're not trapped, that they're not too heavy. It's a sad fact, but it's better to let one person die or be trapped in there for the fire department to come in and rescue, best case scenario, than it is to have them have two people to rescue and both of you die because you tried to go into a place to rescue somebody and you get yourself trapped. Remember, it's not fire typically that kills somebody, it's smoke inhalation. And so you go into this place that's on fire, it's filled with smoke, you're trying to rescue someone, the whole time you're pulling them out, you're huffing and puffing because, you know, they're heavy. And so you're sucking in all this smoke, next thing you know, you're passing out. So make sure that you're able to rescue them. Next, alert others in the building. The campus police department, Dallas Fire Rescue, the pull station. There are pull stations located at every exit, with the exception of the housing departments. Housing departments, your only pull station in Swiss Tower is going to be at the front door. And in Washington Hall, you won't have the pull station to get to because it's in the fire panel room. They did that because they wanted to ensure that you could verify that there was a fire, where the fire was, before you pull on that, because they didn't want any accidental pulls with children being around. So first, alert the occupants of the building. That's primary. If the alarm is not sounding already, make your way to the nearest pull station. Told you where those are and where the exceptions are. At this point, the FPO should already be alerted, and they would be hopefully alerting the campus police and the fire department. If not, you can switch to the police frequency and alert the campus police and tell them the location, size, type, if known, of the fire and if anyone needs to be rescued. In any situation you don't have radio contact to alert the FPO or campus police, find a landline. There used to be one in every classes, but at least now they're in every hallway. You find a landline, and you dial the 9911 911 from your cell phone, 9911. Or you can call the campus police department. What is your guys' new number?
590. Yep.
59?
Yeah, 9192.
There it is, 5590. Okay, I didn't put it in my notes, so there you go. Supply the location. If you call from a campus phone, it's automatically going to give you the 3909 Swiss Avenue, where the trucks are going to roll, and that's where we want them to roll. Exceptions being if you're at Swiss Tower or Washington Hall, you want them to roll there. What is the address for Swiss Tower?
3900.
3900 Swiss. What's the address for Washington Hall?
1107.
1107 St. Joseph. That's where they're going to be pulling up. Anywhere on campus, though, they're going to pull up right out there where the bollards are, between the library and the Stearns building. At the end of that walkway, that's where they're going to show up. Campus police will meet there. We should probably also have an FPO person there as well. So C, contain and confine the area of the fire. You close the doors, keep others out. That's self-explanatory. If you've got somebody, when you're running through there, you're trying to get the building cleared out, you're shutting the doors, make sure the fire can't spread. And it also helps to keep the oxygen from getting to the fire, to help suffocate it, keep it from spreading. If you find somebody who is not exiting the building, let the campus police know. And report it to your the safety director, your director. Don't let people return to an alarm building. And then finally, after all that's done, after you have rescued any victims, alerted others in the building and the departments, and contained the fire, only then do you look to extinguish the fire. And then only if it's small and manageable. Remember, a fire will double its size every 30 seconds, so you move fast. We'll discuss more on that later. Next, our agenda for today, fire basics, the fire classes and types, how to read an extinguisher label, the limits of our fire extinguishers, fire extinguisher types, and what PASS is. Oh, there's more. We'll also give some cautions and some workplace fire preventions. Okay, moving along. The fire triangle / tetrahedron. It's actually a triangle, but we call it a tetrahedron. Remember that there's actually 4 elements to it. You can't really make a tetrahedron out of this because the 4th element is simply a combination of the 3, so it doesn't quite work. But you need, to have a fire, you need fuel, which is your combustible material. You need enough heat to meet the material combustion temperature. Y'all remember the movie and the book Fahrenheit 451? They usually had to made us read that as kids, Fahrenheit 451. 451 was the temperature that book paper back then burned. Now we've got so many varieties of book paper, you can light them on fire without even trying. And the firemen there actually started fires rather than put them out. Then you need enough oxygen to sustain the combustion. The 4th element that tetrahedron will help you remember is that you need the chemical or exothermic reaction to get the fire. So if you remove oxygen from a fire, it can't burn. You remove the heat from the fire, cool the fire down, which is what water is really good for, you can't burn. And if you remove the fuel, either by dousing it, saturating it, or cutting it off from the heat and the oxygen, it can't burn. Take away the oxygen using something like CO2, it can't burn. Then all of the new ABC dry chem solutions that they make actually target the exothermic reaction. The oxygen will still be there, the fuel will still be able to be burned, and there's still enough heat in there that you don't want to touch it, but it keeps it somehow from chemically reacting with one another so that it can't burn. So essentially, fire extinguishers put out fire by taking away one or more elements of the fire tetrahedron. Any questions? Okay, so for us, as far as fire safety, that means the most preventable thing is to keep sparks away from flammable materials. So you don't place coats or purses near space heaters. You properly put away trash. In one of our areas back in Davidson, when we had it, they had a shredder. And where they put the shredder, there was a power strip right behind it with all these plugs coming out of it. And the shredder would sometimes spit the paper out. So I went in to do some work. I look behind there and I see all this paper, shredded paper nonetheless, covering this extension cord basically. And told them, you're going to have to move this or move the other. Got to keep these things away. See, heat. It's often misunderstood that to create a fire you need a flame or a spark, but really you just need heat that's greater than the material's flash point. I brought a couple of things in here, and I'm going to need my glasses to read them, but if I remember correctly from the last time I did this, the flash points of these are about 120, 125 degrees. That's a typical Texas summer. So we need to keep these stored somewhere out of the heat. Will take a little bit more than them getting hot because of the fact that they're pressurized. Their interior temperature is going to stay a little cooler, but you want to keep them out of 125 degree weather. Oxygen, it's possible to smother a fire. So if you ever set yourself on fire, the stop, drop, and roll, that's really what you're doing, is you're trying to take the oxygen away from your fire. Next, get back to here. Oh, fire safety. Yeah, we did that one. Classes of fire. First, your Class A is your ordinary combustible, such as wood, cloth, and paper. Your Class B is flammable liquids, such as gasoline, oil, oil-based paints, and low-temperature grease. That's important because that comes in a little later. Class C is energized electrical equipment, including wiring, fuse boxes, circuit breakers, machinery, appliances. The Class C fires are not maintainable. Okay? You don't actually subtract the electricity from the equation. Where Class C becomes important is that certain chemicals that you use to try and douse the fires will react with electricity and cause harm. So the Class C is more of the igniting factor of the fire and not actual part of the fire itself. And Class D is combustible metals such as magnesium or sodium. And we really don't have to deal with that too much on campus. The letter symbols A, B, C, and D, we don't so much use anymore. They're still there, but they're really, really small because trying to go international, they're going with the pictograms. So we have all these symbols. The A is for wood, paper, and cloth, and you have a picture of a trash bin with paper and stuff burning. B for gasoline, grease, and oil, you got a gas can there. C for electrical equipment, got a short happening. D for combustible metals, and they really don't have, yeah, there is a symbol for that, but it's really, weird looking. So your types of extinguishers, your Class A, you can see it's just for the paper and wood and ordinary materials, and it has an X over the other two. Class AB is for A and B and not for electrical. This would be something that if you sprayed it on electrical equipment, it might cause a spark to come back to you, so you didn't want that. Class BC won't do paper. That's for high pressure. We'll talk a little bit about that. And then Class A, B, and C, the ones that we mostly use on campus, are for everything. There are special ones that we use. So your Class A used to be, big thing, Class A was your pressurized water models. That's this big guy right here. It's filled with water. You can see the symbols for paper and wood only. And you would simply just pressurize water. Back in the old days, you actually had pumps, and you'd pump it up. But pressurized water, and you just pull it out like that. It's got a high stream pressure valve, and water would come out. And you see why you wouldn't want to use water on gas or oil. Why?
Just spread it.
Yeah, oil and water don't mix. And why wouldn't you want to use water on electrical?
It's indefinite.
Yes. Carbon dioxide. This one was rated for class B and C, not for wood and paper. Again, because you spray it out, it comes out at such force that it would just blow the paper away, because this is just compressed air. It doesn't leave a residue, so it was really handy to use on things like electrical equipment, and you still see them some places today. We don't use it on campus because it requires you to get really close to the fire. It's also very noisy. Well, that woke you up, didn't it? It also, if you use it for an extended period of time, can cause sparks, and they thought that wouldn't be a very good idea either. So we don't use those.
Did Lincoln pull his gun?
No. And dry chem extinguishers. These are the ones that we use most on campus. This is our ones from the golf carts, little 2.5 pounders. And you see these are set for A, B, and C because it attacks the fire at the grouping of the tetrahedron. Another one we have is foam. I don't have a foam per se with me, in the sense that we use those for, used to use those for the IT electrical stuff. The foam would come out. It would be very messy, but it wouldn't hurt the electrical equipment. We use a type of foam, it's called a wet chem, in the kitchens for the high grease areas. So we have that system that dumps the chemicals right on top of the grease pit where we use for all of our fried chicken and stuff, and on our stoves. And we have a handheld one, and as you see, this is a Class K. Get a little bit more into that in a minute. This is a wet chemical, and as you see, there's the symbol right there is a frying pan with a fire coming out of it. And this is designed to take the hot grease. The other chemicals, when they go on, the hot grease will cover it, smother it, but underneath you have the hot grease still bubbling away. And all it takes is for it to bubble up, open up a hole in the chemical that's covering it, hits that oxygen, reignites. So the wet chem gets in there and separates it all and keeps it from spreading. So there's your K. It's used only in kitchens where vegetable oil is used for frying, like Mitchell Kitchen. There's actually one of these in the Mitchell Kitchen. And then we have Halitron 1. It's a class ABC. Looks like this. It has a particularly distinct nozzle, and this is for sensitive electronic equipment. This thing fires out. It expels its expellant very quickly, and it's over and done. So that's why we don't use it all over campus. It's also very expensive. It's designed, it's only a BC, not for wood again, because like the CO2, it goes out really fast. But it's less harmful for mechanical equipments and sensitive electronics, so we use those on campus. More about the K. It's a wet chem potassium acetate based liquid, just in case you're curious, which reacts with the burning oils to form a foam-like substance. If you wish to see what one looks like, it's a very large silver can outside. Okay, we already got that one. Handles the intensity of the heat, the grease. We talked about that. Unfortunately, when you purchase a typical fire extinguisher at your local hardware store, it's probably going to be only an ABC. If you happen to be doing something fun, like boiling your your turkey, Thanksgiving, be very, very careful. Your A, B, and C will smother it, but it's still going to be hot, it's still going to be live, it's still going to be active. I've talked to different fire departments, what they suggested on doing to help that, and they said basically just shoot it and leave. Let the fire department come in. Fire department's going to hit it with water, but they hit it with so much water at so much force that it just wipes it out. One suggestion that I had heard was you take a gallon of milk and pour it on top of the thing, because the fat content in the milk will actually absorb some of the oil, and help douse it. It turns your dry chem into a wet chem. Can be dangerous though. If it's already smothered and you hit that thing right where you hit it, it's going to open up. If air gets to it, it can ignite again. Halotron 1, we talked about that. It's a clean agent, better than CO2, works to cool a fire and rob the fire of oxygen. Any questions on fire extinguisher types? I know we went over it a little bit quickly, but no? Okay. Your fire extinguishers have limits. These portable extinguishers are not designed to fight large or spreading fires. It's kind of funny. Firefighters don't take fire extinguisher training class. A lot of firemen don't even know how to use a fire extinguisher because they're used to coming in with the hoses. But we have different sizes. There's your 2.5, 1A, 10BC. We'll talk about those numbers in a minute. Your 5-pounder, 3A, 40BC, and your 10-pounder, 4A, 60BC. Like I said, the C there doesn't really give a designation of anything other than it's okay to use on, or safe to use on electrical equipment without killing you. It's not that it's good for the electrical equipment. All of these ABC chems will eat through metal, so don't shoot them off near your car. If you do, take your car to the car wash. I keep a 2.5-pounder in my car for emergencies, but I know that once I put the fire out, I need to clean all that up because it's going to eat through the rubber, it's going to eat through the metal. It's very caustic. The A is, well, let me just read through this. They're only for small containable fires. The golf cart size, 2.5 pounds, are only good for about 7.5 seconds of spray. That's this guy. Normal campus extinguishers are the 5-pounders, and they're good for about 15 seconds of spray, twice the 2.5. So guess how long of spray the 10-pounder is? Ah, we heard one. 30 seconds. That's right, twice what the 5s are. Now, even though you would never spray continually, as you want to spray in bursts, 15 seconds is not a lot of spray time. These are not designed for large fires. The labels say how large a fire they can fight. The A classes are based off of the water system, so they're measured in gallons. And you take that number and multiply it by 1.25, and that's how many gallons. We go by the B class system because we just don't use the waters. By the way, this is also measured in gallons. Hard to determine how much square feet they are. There is a very complex system to determine, having to do with sticks and how they're arranged to determine what size of a fire it is. But a simplified version of this is to say that it measures, the B measures relative square footage. So you're looking at the 10B there, relatively 10 square feet. The 40B right there, 40 square feet, thank you. 60B would be?
60 square feet.
Yes, and that's not a lot. Your 10 square feet, I mean, this room is bigger than 10 square feet. What do you imagine this is, about 15 by 15, maybe? So at my house, one of our bedrooms is 10 by 10. It's a very small, actually 10 square feet would be 5 by 5, wouldn't it? 5 times 5 is 10 square feet. 5 by 2, holy cats, 5 by 2. So we're talking about
The size of those desks.
that. Yeah, that. Not a lot. So on the whole, counting square feet is reasonable minimum. So while the 5-pound is a 40, it has 40 square feet, 5-pound. Halotron shows a 5B. This Halotron, 5 square feet, that's all it can do. Let's see. So now you're ready to fight a fire, right? You got all the information you need. You're ready to go up to a fire and just start spraying. And no. What in the world happened there?
So
Okay.
it unhighlighted.
Can you read that? Portable extinguishers are not designed to fight large. Okay. Okay, then we're doing it good. So even against small fires, they're useful only under certain conditions. The operator A must know how to use them. The extinguisher must be within easy reach, in working order, and fully charged. And the extinguisher must match the type of fire being fought. All of our fire extinguishers are near exits. We did that on purpose to get you to have to head toward leaving the building in order to pick one up. Show you how to read these real quick. There's a gauge on it. It's very simple. The line must be in the green. The yellow arrow must be in the green. If it's not, don't use it. Go find another extinguisher. Okay. You look to make sure that everything's in working order. The pin is in there. This little strap is in there. You don't have to worry about whether they're expired or not, because I take care of that. So before you consider fighting a fire, this is the RAC part of the race. You rescue anyone not trapped. You alert the building's alarm system and alert 911 and campus police department. You contain the fire. Then, before you get on to the E part, the extinguish, you determine that the fire is small enough to fight and not spreading, and confirm that your exit path is not being blocked. Then, and only then, well, I guess we have another warning. Never fight a fire if one of the following is true. 1, the fire is spreading beyond the immediate area. 2, the fire could block your escape route. 3, you're unsure how to properly operate the extinguisher. Or 4, the extinguisher is not the right type or fully charged. Right type, you see here. Fully charged, you see there. And these are hung in such a way that you can tell as you're running toward them. They're all facing outward like that. Is it an ABC? Is it a K? Is it an H1? Is the pressure gauge in the green? Is the pin securely zip tied in place? All these can be checked at a glance. If any of these are not correct, the extinguisher cannot be used. Proceed to the exit. The purpose for listing the extinguisher check last is because grabbing the extinguisher to extinguish the fire is the last thing you do. It also forces you to proceed toward the exit to keep you between the fire and the exit at all times. Your safety is most important. So when you do determine, fire's small, I've got my extinguisher, I know how to use it, it's ready to go, let's go see if I can put out that fire. Everybody's been alerted, and I want to take this thing on. First, keep your back to an unobstructed exit. Second, stand 6 to 8 feet away from the fire. Now, I see you all writing, that's good. The actual suggestion here is to stand 6 feet. I have you start at 8 feet and walk up on this. 6 feet is the minimum distance you want to stay away from a fire while you're fighting it. But as you're approaching it, it takes a second to get that extinguisher going. So you stand about 8 feet and then start your spray and walk up on it. That also forces you to keep your aim low. Pull, aim, squeeze, and sweep. You pull a pin. This is your pass. So you have race, rescue, alert, confine, and extinguish. And then you have pass, pull, aim, squeeze, and sweep. You pull a pin. You pull a pin. You aim at the base of the fire. You squeeze the lever, and you sweep side to side, side to side, and just keep walking up on it as it extinguishes, side to side, side to side. You don't want to aim at the top, because that's just the heat. You don't want to aim at the middle. That's not where all the fuel is. It's all down below. So you have your unobstructed exits. All fire extinguishers placed near the exit. We talked about that. 6 to 8 feet. Talked about that. Don't spray into a corner. We had someone do that one time. Got a whole face full of extinguishant. It tastes terrible. It's very corrosive. Keep yourself a safe distance. Be very careful in confined areas. You don't really want to breathe this stuff. You pull a pin, aim at the base where the fuel source is, the lowest point of the fire. Then squeeze the trigger, holding firmly. You've got 2 different types of extinguishers, one with the hose, and then this one. Obviously, if you've got the hose one, keep it tight to your body so that any recoil is caught, and use the hose to aim. If you've got one of these or one of these, hold the extinguisher at the bottom, start here, and then push out and aim with your whole body. Okay. And any questions on the pull, aim, squeeze, and sweep? Any questions on the rescue alert confine extinguish? Good. Y'all already wrote your answers down? Good. Electrical fires. This is the, oh, see you writing again. Major cause of workplace fires is the misuse of electrical equipment or electrical system failure. It results from an overload of fuses, circuits, motors, and outlets, mostly outlets, which is why the fire department does not want electrical cords daisy chained. We'll talk about that in a second. That was too far. Wiring with frayed or worn insulation. You see those things. Report to your supervisor. They get locked out, tagged out, or thrown away. Loose ground connections. Machinery in contact with combustible materials, and defective power tools. By far, the most common cause of workplace fires is electrical. That's why we don't allow hot plates. We limit the use of space heaters. Do you know what the 3 major causes of fire in America during the Christmas season are?
Christmas light?
Overloaded outlets, space heaters, and candles. Extension cords are only to be used temporarily, then unplugged from the wall. An exception is made for the surge protector only for sensitive electronic equipment. Can't stress this enough. Your surge protector is an extension cord. Extension cords are not allowed to be used. This is how the fire code is written. Fire code says extension cords are not to be used except as temporary and then unplugged from the wall when you're done with them. Your surge protector is considered an extension cord. It's written in the fire code. You can't use it. The only reason why the fire department allows it is because they can't figure out a way to write it into the code that would cover all the bases, and so they simply say, we understand that it is necessary to use surge protection for sensitive equipment. So you have your desk lamp plugged into it. The fire inspector comes by, they're going to say, unplug that, plug that into a wall. They will look at everything that's plugged into that surge protector and say, can this be plugged into the wall? If it can, you have to plug it into the wall. If it doesn't fit, guess what? Put in a work order, have Eric put in another plug somewhere. That's it. So, and it's tricky because I have to go around once a year and tell people, I'm sorry, but you can't plug that in. Well, I can have my computer plugged into it. Yes, it's a sensitive electronic device. Your lamp is not. Well, it doesn't reach. Put in a work order. That's all I can say. So, this should also take effect at home. They heat up. Also, sometimes I know we often leave our phone chargers plugged in. Check those things. Those things can get hot. Fire department says, unplug them. All right. If you have any electrical devices that have frayed or worn insulation, turn it into electrical shop for service or disposal. Don't daisy chain cords. Daisy chain is when you plug one extension cord into another. If you or anyone you love uses space heaters, keep all flammables away from the space heater. I know it sounds obvious, but if you're in the habit of, say, tossing your purse under your desk, ladies, it only takes one time of forgetting to have that space heater under there cause a serious fire. We have gone through a lot of trouble to replace all of our space heaters on campus with ones that will shut off if they tip over. Before you do any hot work, most of you guys don't have to worry about that. Or work with a spark or flame, look around you to ensure that there's nothing flammable nearby. We now have hot work permits. Grinding metal is hot work. I know, when I first started looking at the hot work permit stuff, I thought that was just for welding and stuff. No, I found out you use a grinder, that's hot work. Got to get a permit. Because those sparks fly everywhere.
Where do we obtain those permits?
You can get one from Jeanette or get one from me. We have a cage area where we do most of our hot work stuff. The grinder isn't in there though, but all of our welding equipment is, and there are some hanging up there. Fill those things out, give them to me, give them to Jeanette, and we'll take care of them from there. Also, keep your work area clean. Like that great Christian spiritual hymn way back when says, it only takes a spark to get a fire going. So keep your work area clean. Workplace fire prevention, chemical fires. Look at your MSDS. It'll tell you where what your combustible rate is, what's your what's the other volatility rate. You know the difference between combustible and volatile? Volatile is the temperature at which it'll explode. Combustible is the temperature at which it'll start fire. It provides the important fire information. Always review before working with a chemical. It'll also tell you something. I mean, you guys know this. You've had this pounded in your head. always check your MSDS. Always check your MSDS. If something gets in your face, you need to know what you're supposed to do. If you accidentally swallow it, do you induce vomiting? Do you not induce vomiting? If it catches on fire, what are you going to tell the fire department? You have to be able to tell them, this stuff is caustic. This stuff is an oxidizer. This stuff, if you spray water on it, you have a good chance that if you don't kill it, it's going to come flying back in your face. So you need to be able to tell the fire department when they come, if it's a chemical fire, what they're dealing with. This stuff is hazardous material. It'll also, MSDS will tell you the flash point, again, when it'll spark, the reactivity and the compatibility hazards, like your oxidizers, flammable limits, and firefighting measures. So your MSDS is your best friend. It'll tell you what not to use in a fire, alert you whether or not you should be breathing any of the fumes. Know your MSDS. Then flammable liquids, keep them away from ignition sources. Check your MSDS for hazards, flammability, ignition, and flash points. Use with good ventilation. That goes in with your PPE. Store in approved containers that are airtight, closed, metal. We have metal fire cabinets at various places in the FPO, paint shop, HVAC shop, in which all flammable liquids must be stored. You have closable metal garbage cans called kick cans. Any of your greasy, oily rags need to go in there. Do not dispose of oily rags in those big yellow bins. They must be disposed of in properly labeled, sealable metal cans. Keep them away from ignition sources. It's not the liquid gas which burns, it's the gas itself. So an empty container runs a greater risk of explosion than a full container. Like planes at risk when they dump their chemicals, they're not dumping all of their fuel to prevent the plane from exploding. They're actually dumping their fuel so that it doesn't spread and kill everybody else. If they can't land it and the people on the plane die, they don't want everybody else in the vicinity to die from the JP4 turning into napalm. So they empty it all, even though it's a greater chance of explosion, less chance of hurting the other people on the ground. I know, terrible, isn't it? I have to think in those terms of, I'm sorry, you're dead, let's not kill anybody else. So, likewise, since it's the fumes, not the liquid that burns, you have to be careful when fueling your vehicle on really, really cold days. Touch the car before removing the nozzle. We've all gotten those little sparks. I've seen YouTube videos of people who, they answer their phone and So discharge any static electricity and don't use your cell phone when you're pumping gas. It's possible to had a guy in the Army who'd take a cigarette and throw it into a vat of diesel to put it out. Crazy, but he knew there was so much liquid there. Diesel had a higher flash point. It would put the cigarette out every time. I wouldn't recommend it though. Machine rooms and fire cabinets. We have on campus and in housing these yellow fire cabinets. Liquids have to be in there. Gas containers, anything that's volatile. There is absolutely no flammable storage allowed in any mechanical rooms. We had this issue over at Swiss Tower. The fire inspector came by and said, this says mechanical room on it. Well, that's because when we first put the building up, we were going to put the electrical stuff in there. So it says, it says electrical is what it said on it. And she says, if it says electrical, even if there's no electrical equipment in there, it's an electrical room and you have to move all of your storage out. Well, the other side said storage, but it had a bunch of electrical equipment in it. So she says, well, you can store non-combustibles in here as long as it's with, 30 inches away in all directions from whatever you need to get to, whatever the electrical source is, the mechanical source. Stay 30 inches away and non-flammable. So I said, okay, I've got a solution. Rip, plop, plop. Now that's a storage, and that's electrical. And she goes, well, if it's okay with the building inspector, it's okay with me. Went downtown, talked to the building inspector, called him first, went down there, and he says, I don't care what you name your rooms. I said, good enough. So we switched the signs. That one's storage now. So we put all of our flammable storage in the ones that don't have electrical panels in them. The ones that have electrical panels, we can't have any flammable stuff in it, but we can store non-flammable stuff as long as it's 30 inches away from the electrical panel. So those are the rules. So clean up after yourself when you go into a machine room. Do not leave any trash behind. Do not leave any, and custodians, you guys, you're our eyes and ears. You walk into a mechanical room or any room with electrical and you see garbage in there, give us a call, let us know. That stuff has to come out of there. Won't mention any culprits, but we have a couple of people, contractors, that are notorious for leaving their trash. Let's see, we talked about that. Okay, 30 inches. That's your puppy. In summary, you have the fire triangle / tetrahedron. Remember what that is? Heat, oxygen, fire, fuel. Heat, oxygen, fuel, and then the combination of them. You have the 4 classes of fire that we typically deal with, A, B, C, D. Your extinguisher types, A, B, C, D, K, halotron 1 or H1. And then we have pass, which is your pull, aim, squeeze, and sweep, and also race, which was
Rescue radio.
rescue, alert, confine, and extinguish. Good, good, good.